All right, so welcome back to my series of solving advent of code puzzles in Go. And today we will solve the day 17. We are at day 2015 still. The idea behind the puzzle today is that we have too much of eggnog and then we need to store it in different containers. So we have a different containers, different capacities, and we need to have the combinations of these containers which sum exactly to the same amount of liquids or eggnog that we have. And for the example, we have 25 liters and we have 1, 2, 3, 4, 5 containers 20, 15, 10, 5, and 5. And if we calculate the different combinations to have some exact 25 liters is 15 and 10 and 25 and the first 5 and then 20 and 5 so the second 5 so it's counted 2 times, and we could also have 15 and the first 5 and the second 5. So if we have two containers with the same size, they are two containers, completely different containers, not the same container. And for the actual puzzle or puzzle input, it's 150 liters. But we will start with the proof of concept to solve the small one, and then we put the actual input. And this one in computer science called subset problem. If somebody interested, you can read about it. It's interesting. And yeah, let's get started. So what I've done, I prepared the solutions for the first one, not the solution. I prepared the skeleton. So I added the register for the init of the plugin, and then I add the solve function. I added buckets, or it could be buckets or containers. It's up to you. And then I'm just reading from the file. So the file is containing only the sample containers 20, 15, 10, and 5 and 5. And then I'm converting them to integer using or to int using str convert package and using a to I. And then I don't care about the parsing error since the solution or the input is really clear and it's correct. So yeah, so let's print it out and see how it is. So go run day 17. So the sample that we have is a list of containers that we have. So find what we need to find combinations. So to find combinations, we need the combinations of what we need to find. We need to find the bucket list or buckets or containers and its array of int, and we need to find the target. So the target is int. So we need to find how much we need to fill, which is 25 for the first case and the second case 120 or whatever. What we need to send, we need to send an array of array or slice of slice or two-dimensional slice of integer which contain the each slice of this two-dimensional slice is a complete combination of what we could use. Okay, so to start this one, let's start with this sample of buckets. What we have, we need to solve it. We have two routes. First route that we take the first item, so we need to calculate. So let's write it here. So we need to find the containers for sum of 25, and we have the 20, 15, and etc. So we have two ideas. So we have the target is 25. Target is 25. So even we take the first bucket or first container or we leave it. So we need the first bucket. First bucket is buckets 0, and we need the rest of buckets is from the second item until the end. So here what we will have 20 in the example case, and what we will have here 15, 10, 5, and 5. So even we can take the first element. If we took the first element, we need to find, we took the first element is 20. So let's take the 20. Target now is 25 minus 20, which is 5. So we need to find the buckets, the rest of the buckets. So we need to find with a 5, 15, 10, 5, and 5. We need to find the target 5. So the first one doesn't work, the second one doesn't work, the third one work, and then the fourth also works. So we will have two combinations from the first run, which is 20 and the first 5 and 20 and the second 5. And the second approach or the second way that we need to take, we leave the 20. So we don't take it. In this way, we will have the target still 25, and we need to find 25 with the rest, where the rest are 15, 10, 5, and 5. And then when we go to find it, since it's recursive, what we need to do, we need to find in the second step, we need to find the from the array like 15, 10, 5, and 5, we need to find target 25. So we also have the same. So we will have the 15 as a first element. So even we take it or leave it. So if we took it, we take the 15 and then we took the 10 or 15 plus 5 plus 5. So we have a different combinations and different scenarios to do it. So to solve it, we need to, let's say, take the first. What we need to do, we need to find the combinations also, but we need to find the combinations for the rest of the buckets, and the target must be the target minus the first bucket. So since we already have the first, the result has no first, so we need to combine with the first element. For this, we need to go for each element. We don't care about the element itself. We go with the range, take the first, and what we need to do, take the first. For item I equals append, we add this first one and then we add the first bucket. So for this one, if we choose 5, we will do 20 plus 5, and then we will have 20 plus the second 5. And then the other root, leave the first. If we left the first, we need to find the combinations also of the, we need to find it for the all buckets, but the target is still intact. But this is cause recursion, so we just remove the first one, we need to find the rest of the buckets. So we just drop the first one. And the final combination is the combinations between the scenarios that we took the first one and left the first one. So we return append the take the first and leave the first. But this is will go to infinite loop. So what we need to do, we need to stop conditions. So if target is 0, so we reach the end, we return empty items, empty array. We don't need it because it will be combined from the previous runs. If the target is less than 0, it's not possible to have minus, so they need to be full completely. So we return nil. And if the buckets also, or the links of the buckets that we don't have any containers anymore, this is also could be nil. So we could also equals null. Okay, so This one, both of them, they could be combined, but we just leave them for the sake of clarity. In this case, I think it's clear. So see what the linter said. So we could just go with the remove the empty one. So yeah, this from Go optimizations. Okay, so what we need to do now, so this is the buckets. Let's have target equals 25, and then we have combinations. Find combinations of the buckets and the target, and let's print all the combinations. So let's combinations. Let's print them. It's empty. So why? Buckets target buckets target. Okay. Mm-hmm. Oh, sorry. I'm returning empty here. It's supposed to be return the target itself. So it's not working like this. Buckets. So let's return the buckets. Now it's correct. So you see now we have it as correct, but I'm not sure why it's not combinatory. It's actually target, not the buckets. Yeah, now it's correct, but it's not zero. If it's zero, mm-hmm. No, actually, it's correct. It's empty. It's supposed to be empty. Yeah, it's supposed to be empty. I don't know what's the issue. I think it's just the quotation. It was a single array, but it's supposed to be so this is a 2D slice. So this is 2D slice, and we need to add two of these brackets. And the issue was I'm receiving only one, and it's not correct. So uh, now it works. Let's see, like it's 520, 520. So this is the first five, the second five, and this is 10 and 15, the first, second, and 15. Okay, so it seems correct now. So let's see what they need exactly. Uh, it's four way, so they need just the number of combinations. So format dot print f part one, number of combinations is digit, and length combinations. So this is we supposed to get 4. It's correct. Let's replace it with the actual input. So this is the actual input. Oh, that's okay. So this is the actual input. Yeah. Okay. Let's close it. It's 3 combinations. Wow. I thought it will be really more. It's just a 3 combinations. Okay. Let me check if I'm recording. Yes, I'm recording. So it's 3. Uh-oh. It's wrong. Hmm. Yeah, the target is wrong. So the target is 150. Yes, 1304. So let's try it. 1304. We have to wait 29 seconds. Let's wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 1304. Let's try again. 1304. Yes, we got 1 star. Okay, so let's see the second one. While playing with all the containers in the kitchen, another load of eggnog arrives. The the shipping and receiving department is requesting as many containers as you can spare. Okay. Find the minimum number of containers that exactly fit. Uh, okay, so it's easy. What I will do. So to solve the part two, what we need to do, uh, we need to save the minimum, the number of combinations, and each number of combinations. How many? So let's say we could have 150 liters with three containers. We could have five different combination of or four different combinations of these three containers, and we could have seven containers, um, like two times or whatever the number, and then we need to find how many combinations that we can have, the minimum amount. So the minimum amount is three containers. How many combinations of these three containers we could have? So the first thing we need to do two things. We need to find for each combinations for each number of combinations, how many of these combinations are there. So let's uh, minimum or combinations length length. Let's say like this is an array or map. The first item is int and the second item is int. And for, let's say, minimum is the length of the combination of the first combination. So let's try to print out the combinations to explain it more. So if we print ln the combinations just for the test, so you see it's very long list. Let's take the first one. So the first one is 1, 2, 3, 4, 5, 6, 7, 8. So the links of 8, and we will need to find how many links of 8 are there. So the minimum links is the links of the first one for start, links of the first one, and then for I in range length of combinations. How many combinations? Okay, so if minimum is less than the length of combinations at I, minimum equals the length of combinations at I, as simple as it is. And what we need to do, we need to have this array, so or this map. So what we need to do before actually solving this one, we need to have the first element. So we will have it as combination if, let's say, okay, value combination length of length oh, let's say length equal length combinations I. So length combinations of value combinations length, this one, the length, and then what we need to do, if okay, what we need to do, oh, actually value, and then okay, I always flip them. So if there is a value, we need the combination length equals value plus 1. Otherwise, we set it to 0. Length equals 1. So I think this is correct. So if we try to print it out, see how it will, no, print combinations links. See, now what we will have uh, the links 4, it has been appeared 14 times. The links 5, 180 times. The links 6, 4 something. And if we combine them together, or if we sum them together, we will reach is 1304 with the total. So what we need now we have the maximum or the map, and then we have the minimum. So the minimum is print ln minimum is minimum. So the minimum is 9. How is the minimum is 9? The minimum length minimum is length. If length is minimum is length. Okay, now it's correct. It's 4, yeah. I just flip the condition. And what we need to do now, we need to find the minimum number of containers was 2. Okay, so for this one, like 1, 2, 2, and 3. And then there were 3 ways that the containers would be. Okay, so it's quite straightforward. So part 2 is combination length of minimum. That's it. So if we try to print it, so let's go one line after the decimal here, after the digit. We go with part 2, the ways, just part 2. I just have it as a part 2. No need to. Part 2, D, and part 2. Let's see. Part 2 is 18. So if we try to find, this is for its 18 way to do it. So this is 18 way. Oh, just space. Remove the space. Yes, it's correct. Yeah. So like I think 1, 2, 3, 4, 5, 6, 7, 8 days to go. Okay. Thanks for staying here, and see you in day 18.